All right, so Drew. Today is the 27th of March, 2023.
Be quiet.
All right, the lesson has begun. I know that there's noise coming from the acres because they're watching videos. Thank you. Oh, Henry has a question right off the bat. Yes, he probably has a question about the terminology.
Yeah, and also, is that just, why are these swords so dirty and that one's so beautifully clean?
That's a great question. I don't know.
Can we wash them?
Was that the original color?
Washing
of all
them won't
these?
make them go back to that color.
But it will.
But it won't, because I have
I
sent
can
the
use
last
Dawn
one.
dish soap.
Dawn is the answer?
It's Dawn power wash.
Dawn power wash.
And now that Henry's asked his excellent question of what does similar mean, I will answer his question by saying similar means that a shape has been either scaled up or scaled down, but they stay proportional. So I'll say they stay proportional.
It can change, but it has the same proportions.
They stay proportional. So for an example of some, like, I'm thinking in my mind like an evil scientist that has like a growth ray or a shrink ray, and then they have maybe a malfunction where I have a shape that looks like this, and they're like, I want to make it get bigger, and then they go like that. It's like, yeah, this length should have changed too. You forgot to change that length. These are not proportional. Only a bit of it got grown. I need all of it to grow uniformly or all of it to shrink uniformly. So that would be a bad example. So I'm going to go ahead and erase my bad example. And you can see it's been used.
Don't use it! Don't use it!
We're going to make them all look uniform.
It's beautiful.
So something that stays proportional means I have some shape. Maybe it looks like that. And then if I want to make it bigger, let me see. This is something that Finley and I are going to have to deal with. A little bit longer, and then like that, and then like that.
Yes.
Yeah, yeah.
Yes.
So now my growth ray is actually functioning. I didn't just grow a single part of it. So those stay proportional. The cool thing about your growth rate and your shrink rate is it has some scale that you set the shrink rate or growth rate to. You can be like, all right, to get from here to here, you always multiply by something. So the thing is, you don't know what to multiply by until I give you some numbers. So what if I told you that that length right here was, you guys like the number 7? And I tell you that length right here is 21. Then, boom, you got it already. Then you know to get from 7 to 21, you're only allowed to multiply. You're never allowed to add or subtract. Only multiply. I guess division is also okay. To get from 7 to 21, yeah, you multiply by 3. So if I tell you something like, that's 6, then you should be able to tell me the missing side. Like if that's
18!
X.
18!
Yeah, you guys are already, I'm done with the lesson essentially. Yes, you just say, okay, I know the growth factor, getting from here to here, so I find that first, and then I can say, oh yeah, to get from 6 to X, you're going to multiply by 3, and I get X is equal to 6 times 3, which is equal to 18.
Oh, big brain.
Okay. What if I give you something a little bit trickier? What happens if I give you something that looks like this? What happens if I give you a 12 right here and I put a Y right there? Then how would I find Y?
Y? Divide by 3 and it's 4!
Well, I feel like I'm not really teaching
I just
you guys.
like
You
this
guys already know
math.
everything.
I like this math. It's
You
sticking
go from
out.
here to here, you multiply. So if you want to go backwards in time, instead of multiplying, you're going to divide to go backwards, the inverse operation. So to go from 12 to Y, you'd say, yeah, divide by 3. Y is equal to 12 divided by 3, which is equal to 4. So I will try to trick you. The only thing that I can really do to trick you, I'm not, will I ever make the scale factor a decimal?
No!
Yeah.
No, no.
No, wait, what are you gonna do? I was zoning out.
So that's like an easy example. Let me show you a harder example as I take a drink of water and let Finley get caught up because she's like freaking out that she's only like halfway.
Yeah, you're pressuring Finley.
Oh my god.
Finley, no pressure. This is only nuts for all. That is very good handwriting, my friend. You should like donate your hand to me.
Have you seen my handwriting?
Have you seen my handwriting? You can't tell my H's from my N's. I write.
You can't even tell a word.
My N's look like H's. You can't really.
I could.
Yes, you do.
Oh, I need to tell you guys a cool history fact that you probably didn't know.
No
About math.
way.
It's not really about math. It's about, do you guys know that much about King Arthur?
No.
The eighth. King Arthur the eighth.
You know, have you guys ever watched Monty Python and the Quest for the Holy Grail?
No.
What's a python?
You will, Mr. Godoy will make you watch it in high school. It's an excellent movie. It is hilarious. It's very dry British humor. But anyway, King Arthur, they have like the Knights of the Round Table, Quest for the Holy Grail. Strike any bells?
Yeah.
No.
In Transformers, they have Knights of the Round Table.
Transformer.
Did you know?
the coolest
At
thing.
Universal, there's
I'm not even
Transformers,
joking.
right? And
When
did we get to that?
They're like cars, and then they
Yeah,
bro, I've been in that.
They were the original.
One of the things that King Arthur was well known for is the round table, which is weird because typically speaking, when you're, and this is stuff that Finley does not have to copy down. Typically speaking, when you sit at a table, the table is usually this shape, and usually the king would sit at the end of the table, and then people that were like close to him, like his wife or a diplomat, would get to sit nice and close. But then King Arthur kind of flipped on his head and said, I'm gonna have a round table, and it doesn't really matter who's at the head of the table because there is no head of the table. So that was kind of an improvement. But did you know that King Arthur wasn't the one that came up with the idea of the round table?
Albert Einstein.
Yeah,
Einstein came after, but nice try. It was actually one of his knights. I actually happen to know that knight's name. Would you like to know?
Yes.
King Arthur the third.
His name was Sir.
William.
William.
Curly.
Crawford.
Cucumber.
Cucumber. Caterpillar.
His name was Sir Comforts.
Oh, Sir Cup. Are you kidding me? Sir, what? Actually, his name was Sir. Oh, Mr. Sindel, joking us with a funny pun.
Oh man.
How hilarious.
Did I solve enough, Finley? Are we caught up?
Circumference.
I'm
I want to learn more about circumference.
Stall more.
Alright, that was, I guess we can tell that example one.
No, please don't. Tell us about Riley.
Riley is super cute. Did you know that?
He bullies me, Mr. Snow. Obviously. He bullies me.
You need to make him stop that. Let's do example two.
Yeah, let's become like big buff.
No, he bullies me.
Now Riley's like,
He's eventually going to be towering over people, and like a really tall bully is a scary bully, so we do that.
I know, Lex, you're
Quit
getting
that now.
studied by like a.
That's
Alright.
gonna be your
Like
fault if
2
you get like a
Okay,
loud
I'm
voice.
gonna make
Knows
example
like
2
12
the
words.
hardest possible example, and then we can call it done with the notes, right?
You
So,
get it.
one thing that I can do too is I can rotate the figure. So these figures were not rotated, I just kind of made it larger and bigger next to the side. I'm gonna go ahead and rotate this next one, so you'll have to be careful. And on top of that, I'm gonna make this multiply thing a weird fraction.
Is it fraction?
Alright, so what do I want to do here?
Yeah.
I want
So you just divide.
Alright, I'm gonna put a right triangle. Notice there's that little symbol that means 90 degrees. Right
That's
angle.
a square.
Nah, I think that's a triangle. No, oh, I got
Oh,
it right.
look, that one's a right triangle too, but it's a little bit twisted.
It's
And like flipping doing things.
It's
Oh man.
lopsided.
Alright, I'm gonna tell you that this is 8 and this is 6. Not drawn to scale because I'm
48.
not the best
What if
artist.
they're not?
So growth mindset, I can be a better artist. I just need to keep practicing. Yes, I like to get from here to here. I don't know. I multiply by some number.
1 something.
1.5.
If I multiply
be a
by 1.5, it'll get even bigger.
Fraction.
One and one half.
So if I get even bigger from 8, that would be like
Wait,
9.
aren't you dividing?
Oh, I have to go smaller.
No, divide.
I might have to be dividing. I don't know. I'm going to show you right now a magical method that will always get you from here to here. To find that number, it's always the same thing over and over.
Plus 2.
And you just add 2. Done. Like, just start with it. You have to multiply by something.
That's
I know.
Last year,
You liar!
lecturer like it was like no, in the background. You're
So I'm going to show you that method over here, which you didn't need because this one was so easy. Did you know that if I take right divided by left, you'll always get this number? Watch, watch, watch. Ready? If I take right divided by left, you'll always get the, this is known as a word that I'll teach you about right now. This is called the scale factor. I just need a name. I don't want to call him Billy Bob Joe because you'll forget about Billy Bob Joe, but scale factor, everyone else also knows this as the scale factor. To find that scale factor, maybe I can, I'm getting formal about my math, watch this. Scale factor is equal to right divided by left. So if I do 21, which is the right number, divided by the left number, 21 divided by the left number, I get 3, which means that's the scale factor. You always find the scale factor by doing, this is still not formally correct, right divided by left, because what if I put that shape over there? Then it's backwards, right? So it's just a simple formula. We can make it more formal later in high school.
So 8 divided by 6?
So we're going to do right divided by left. Watch this. I'm going to say our scale factor over here.
Our Billy Bob Joe is.
Our Billy Bob Joe is right divided by left. And right was 6. Left was 8. And I can reduce that fraction.
2!
Yep, you already see I can divide the top and bottom. Alexa already told us by 2.
I just get this.
So our scale factor here is you multiply by 3/4. And again, you could think of this, oh yeah, multiply by 3/4. If you want to divide, by the way, you need to flip it. If you want to divide, it's going to be left divided by right instead of right divided by left. But I usually always think of this thing as multiply. That way I just have one formula that I can use over and over again.
Are you serious right now?
So, let's check. Do you know how to do this? Did you know that this length right here was, it has to be a right angle.
21.
This is not going to be a right triangle, so I'm a little bit of a liar. I'm going to go ahead and do this so I'm not a liar.
It's a square.
I'm no longer a right triangle, so that way I can make this problem work out.
You're a wrong.
I'm going to make you 12. And I'm going to make you X. And I'm going to make you Y. I'm going to make you, wait.
What? Where did all these letters come from?
I'm going to leave it at that. I don't want to go too far. Alright. Did you know that long, I'm putting air quotes leg because it's not a right triangle, that long leg and that X are the same corresponding part? If I rotate them, I'll eventually, those will match up. So how do I get from 12 to X? What do I have to multiply by?
1 3/4.
So here's X. Find X. I'm going to say 12 times 3/4 is X. So maybe I'll make that a little equal to. Cool. How do I do that without a calculator?
12 times 3 equals.
You put it
36. 36 over 48.
36 over 4?
48.
That way works. That way 100% works.
is 0.75.
That also works, yes. Can I show you guys the way that I would do it, the fastest and most efficient way?
Yeah.
This right here says multiply by 3 and then divide by 4. But I know that multiplication and division happen at the same level. I can do division and then my multiplication. I'm going to divide by 4 first and then I'm going to multiply.
3 times. Wait, say it again. I like
12 divided by 4.
9.
12 divided by 4. We all shout out.
3.
And then 3 times.
9.
It's the big 1, 0.
I don't like this one. I like the others.
You're backwards.
All right. Are you ready? Set. The hardest problem I can give you is I can make that the Y, and I can tell you that length right there is, I don't know, give me something that is a multiple of 3, like 15.
15.
9.
15?
9.
That's a kind of a big number. But I'll do it. Okay. So to get from here to here, I would multiply by 3/4, but I'm trying to go backwards.
So you divide.
You division.
So I have 15, and I'm going to divide
You need an
by
11.
3/4. Done.
Wow.
Oh, division with fractions. What do we do?
Keep change flip.
It's a cheat. Keep it.
Keep it changed.
Is equal to keep it, change it, flip it. All right. Do you want to do? Do you want to multiply first, or do you want to divide first?
No. 15 divided by 3 is 5. 20. 20. It's 20, y'all.
Wait, that goes to 1. I don't know what I'm thinking.
20.
1 and 5. 5 times 4.
20. The big 2 zeros.
We're so good.
That's the hardest example I can throw at you.
We're too good at this.
Yeah, I don't know if I even need to do a lesson, but I did a lesson. There it is. Little figures. Just purely based on example 2. If I gave you example 2 now with like fractions, rotation happening here, going forwards and backwards. This 5, how well could we do?
Wait,
See,
example 2?
Example 2, purely example 2, yeah. And I identified all the hard bits, right? I've seen 4, drum, come on, Merrick. This 5, this 5, this 5, 5,
3.5.
3.5, 4.
3.5.
Oh, wait,
So
I
catching
meant
up.
4.
4,
Sorry, my
4,
bad.
4, right?
Sorry, my bad. I meant 4.
Not like amazing.